name is Gavin Joyce. I was lucky enough to join Intercom about 3 years ago. I was also lucky to get the opportunity to make the case for Ember and Intercom. I was certain at that point that if we adopted Ember, it would enable us to significantly raise the bar on what was possible in productivity and our ambitions. At the time, 2 colleagues and I set out to build a simple part of Intercom and Ember just to prove how productive we could be. And 3 years later, we're now a much larger company. 129 engineers as of today have made contributions to our main Ember application, which is called EmberConf. Most engineers in Intercom are full stack engineers, so Ember's strong conventions and tooling are extremely valuable in helping them to be productive and to build amazing products for our customers, which our customers love. I think we've got many things right in Intercom over that time. Not necessarily the most important metric, but certainly a useful one. We've grown our annual recurring revenue from 1 million to 50 million in the last 3 years, making us one of the top handful of fastest growing SaaS companies of our generation. We introduced Ember 3 years ago. Coincidence? Of course, we got a number of things right, and we quickly fixed things that didn't go so well. But Ember has certainly been a big factor in our success and will likely continue to be as we go on to build even greater things. As we grow, and I've been lucky enough to evolve my own role in Intercom to do some open source stuff and work on Ember community stuff. I also dabble a little with making Ember videos on YouTube. So when deciding to submit this talk, I decided to stretch myself a little and learn some animation so that I could make better videos in future. Also, if by doing it on Ember internals, I could learn more about how Ember actually works and expand the areas of Ember that I could contribute to. This talk might get a little bit technical at times, but hopefully it's useful to you in building up a better mental model of how some of the things inside Ember work. So here's a simple little Ember application which we'll go deep on and examine the detail. It's got an image and 2 buttons. The pink button uses a classic action and the blue button uses the closure action. You can see that clicking either button simply toggles the image. Here's the JavaScript for our app. There's a show image property which defaults to true and a single toggle action which toggles the show image property, true, false. And here's our app's handlebars template. First, we have an if statement. When show image is true, we render a static image. And then the 2 buttons, the first uses the classic action, the second uses the closure action. Both buttons trigger the same toggle action. Let's first look at some of the high-level differences between the 2 actions. The classic action uses what's internally called an element modifier, in this case an action element modifier. And that's the action toggle text in the curly braces. And the closure action on the right uses what's called the action helper to assign a function to the on-click attribute of the button. The syntax of these 2 ways of defining actions are quite similar, however, how they operate is quite different. Looking at the final rendered HTML, we can see further differences. The classic action on the left has 2 data Ember action attributes defined, whereas the closure button on the right does not. Looking at a representation of the rendered DOM, you can see that the pink classic action button doesn't have a direct click handler defined on it, whereas the blue closure action on the right does. And you can see that clicking on the pink one triggers the handler on the body, while clicking the one on the closure action triggers the handler on it. There are 4 interesting phases of the app which we'll look at: boot, initial render, action dispatch, and then re-render. A number of interesting things happen at boot time in an Ember app. I was planning to outline them here in my talk. However, a couple of weeks ago, Mike North released a great video which details Ember's boot process pretty much exactly as I'd planned. So if you're interested, I very much recommend you watch that. It's pretty great. And if you like it, you should also follow him. So you encourage him maybe to create more of these videos because they're really fantastic. One part of the boot process that I will highlight is the setup of a set of event handlers on the root element for your app, which by default is the body element. These can be configured, but by default is 27, covering touch, key presses, mouse movement, and they're set up on the body element. If we were to define a double-click event in a component, it's the double-click event on the body that's actually fired. And within this event handler, the target component is located, and the event is then dispatched to it. So the second phase, initial render. To do this, we're going to dive deep into Glimmer internals. So as an introduction, we'll start with an even simpler app. This is a Hello World app, renders a static piece of text. It's template, it's got a paragraph with a piece of text in it. Hello, EmberConf. Hello. At build time, Ember CLI compiles this into a form known as the wire format. All templates in an Ember application are compiled at build time into a form like this, and then they're then packaged up into your JavaScript payload for your app and delivered to the user. In contrast with earlier versions of Ember rendering engines, the wire format is just JSON data and compares very favorably in terms of payload size and initial parse time to earlier template representations, which were bulkier JavaScript functions. At runtime, there's then a second just-in-time compilation step where Ember compiles the templates from wire format into runtime opcodes, which are then executed in a virtual machine. Both of these compilation steps are very interesting themselves. However, I'll just skip over those details and focus on the execution of the opcodes at runtime. You can see on the left the opcodes being executed one by one, and one of the results of that execution is the initial render of our application in the browser. Here's the actual list of opcodes that get rendered on initial render for our simple static app, 33 in all. I won't go into details of these. Some are for the root of our app, some are for the application controller, and the top-level outlet. Here's the 4 for our application template. And on initial render, this single program of opcodes is executed in sequence. Obviously, the more complicated your application will be in terms of HTML tags, components, helpers, if statements for each iterators, the bigger this list of opcodes will be, but it's executed from start to finish in a single pass. The Glimmer rendering engine is actually made up of 2 different virtual machines. The append VM, which is for rendering content on initial render, and then the update VM, which is for rendering content updates. So the append VM is on the left, the update is on the right. As the append VM executes, it can emit update opcodes as it encounters any dynamic content. And then when we render, it's only the update VM operations that are executed. As Glimmer has detailed information on what is static and what is dynamic in your templates, and it knows in detail which dependencies any dynamic content has, the update VM opcodes can describe a perfectly terse set of DOM operations. And this is what allows Glimmer to be so fast at updates when compared to even the fastest of DOM diffing implementations like Inferno, React, and React. So let's zoom into some of the details of Glimmer's append VM as it's about to render the opcodes from our simple hello EmberConf template. So here you see the 4 opcodes which will be executed: open element, flush element, text, and close element. There are a number of moving parts within the append VM. I've highlighted 2 of them here which are interesting for our first simple example. Constructing is a simple variable which points to a DOM element when we're building it. And the element stack is a stack of DOM elements, and at any single point in time, it represents a path from the topmost DOM element to the DOM element that were most recently inserted. On the right, we have a view of the HTML for application and a representation of the DOM. And I've simplified this a little to exclude DOM nodes such as the body. So we'll step through these one by one in a second, but first I'll just let it play through so we can get a feel for the moving parts. The first opcode open element has a single argument which indicates which element we're going to create, a paragraph in this case. Each opcode maps to a simple function in Glimmer. In the first line, we create our paragraph DOM node. This DOM is an abstraction which allows Glimmer to run in different environments. In Fastboot, we're running a node, so we don't have access to a real DOM, so it's a representation of that. So we create a representation of a paragraph node. In the browser, we do have access, so it creates a real paragraph DOM node. In line 2, we set this new element to constructing, and we're done. On the bottom left, you'll see that we put the paragraph there in constructing. Interestingly, it hasn't been inserted into the DOM yet. If we had additional operations, such as attributes or classes, they would happen in subsequent opcodes. And then when we're finished with those, we would insert it into the DOM. But in this case, we don't, so the next opcode is flush element, where we grab the parent node from the element stack, which in this case will be the div from our surrounding controller. We then grab the element that we're constructing, the paragraph node, and we insert it into the parent div as the first child. Finally, we set the constructing to null as we're finished building the node. Next, we have a text opcode with a single argument, which contains the text. And this simply creates the text node and inserts it into the DOM. Finally, we have a close element, and this pops an element from the element stack. We're finished rendering it. So let's look at the initial render of our image toggling application in the append VM. As before, we'll run through the animation once before stepping through it, opcode by opcode. There's a lot more going on in this. It took me 3 days. 3 days. So it's constructing the second button now, and then it'll construct the third. This would be so much easier if it was just like one slide and I just talk for 5 minutes. So as before, let's step through the opcodes one by one. The first is putargs, which has a single argument containing the compiled arguments for our if statement. Our if statement, in this case, is a single positional argument, show image, and the compile self base represents the disk scope that we're currently executing under, which in our case is the context of the controller that contains both the show image property and the toggle action. In the first line, we evaluate the compiled args, wrapping the raw compiled arguments with references. If you're not familiar with references, Godfrey and Yehuda's talk from last year, EmberConf, they spoke in detail about them. And there's also some great technical docs on the Glimmer VM repo. I'll tweet links to these and the video after the talk. For now, though, you can consider references as simple wrapper objects to a value or some lazily computed value. In JavaScript, if you pass a Boolean to a function, it's passed by value, meaning that if you change it in the original location, it doesn't update in the place you pass it to. But with a reference, because it's an object that wraps the value, you can pass it around and change the value, and it will update everywhere. So we have these references, and we grab the first positional reference, which in our case is a reference which wraps the show image property. And then we set the args and the operand reference in the current VM frame. Frames capture the current state of our VM as we render a hierarchy of components and if statements and things like that. The next opcode is test. First, we grab the operand, which we just placed in the current frame, which is the show image reference. We then wrap this reference in a conditional reference. When computed, this reference simply casts the value of the show image reference into a boolean, and this is what gives Ember if statements their truthy semantics. So if the value of the operand was an array with items, this conditional reference would cast that to true, and if it had no items, it would be false. We then set this reference as the condition on the frame. So the enter opcode first captures the current state of the frame, and then we construct a try opcode, which actually will be run on the updating VM. Now, if you think about it, we're currently processing an if statement, which has a dynamic argument show image, and that might change in future. And when it does change, we know that we're going to have to update the DOM, either to remove the image element if show image flips to false, or render a new image if it comes true. So this try opcode represents the bounds of that possible work, and we'll see how this works in a little bit later when we look at the append, or when we look at the update VM. The append VM is a list of updating opcodes for the update VM, and we just add our try opcode to it. You can see it fly over there. So jump unless is next. It gets our show image conditional reference from the current frame. As references can represent the arbitrary computation of a value, and this computation can be expensive, we wrap the reference in a cache. Glimmer has a ticket-based system which allows it to avoid recomputing reference values unless necessary. For example, if we were to do an initial render of our app and take a ticket, and then do a re-render without changing any dependent data, we could simply skip all the re-rendering work as the ticket would still be valid. And Glimmer also uses tickets recursively, so even if some of the dependent values changed, it could still avoid large amounts of work where those tickets are still valid. As with the references, there are good docs in the Glimmer VM for this. Now that we have the cache, we can peek at its value. If it was false, we would skip ahead to some target opcode. That's the vm.goto. Basically, they would jump over the if statement, or if we had an else statement, it would jump to the else opcodes. Right now, show image is true, however, so we don't jump. And we finally emit a third opcode for the update VM, passing in our cache reference. And we'll dig into that when we cover re-rendering soon. So now we're entering in the block, and we have an evaluate opcode. This receives a block of wire format statements, so the ones that were delivered over the wire. In this case, these statements describe the block within our if statement, which is an image. We grab the arguments from the current frame, then just in time compile the wire format into new append opcodes, and we push a new frame onto the frame stack with these new opcodes. So you see lots of things moving there, but we've got new opcodes inserted there. And now that we've compiled and injected these opcodes, we can start processing them. We've seen open element before, constructs a new DOM and sets it to construction. Static adder sets an attribute on the element we're constructing. In this case, it sets an image source to point to our Tomster image path. And then we flush the element, which we've also seen before, takes the image node and inserts it into the DOM. At this point, our image would be visible if we were to view the application. Close element pops the image from the element stack as we're finished with it, and we exit our block. Now we're on to the first button. So there's an open element, which is skipped over there, and then we reach a modifier opcode. So this represents the classic action toggle statement in our classic action button, which represents an element modifier. This modifier opcode receives two arguments: action modifier manager, which provides lifecycle hooks for our our action modifiers, so for creating, installing, and deleting them. And the second argument is the compiled arguments, which contain the name of the action toggle in this case. Let's see if you notice where I had to patch some data there. So we grab the element, our button. We then evaluate the args, which wraps them in references. And then we ask our action modifier manager to create a new action modifier, passing our button element as the evaled args. This creates a new action state object, which contains enough information at runtime to dispatch an event to a particular target. So when the button is clicked, Ember's body click handler will fire, and if the target element has an ID in it, we'll get this action state from some registry and then dispatch action to its target, which in this case is the controller. The modifier and the manager are then scheduled for installation. The append VM opcodes run in a transaction, and when that transaction is committed, things that are scheduled are then executed. This is one of those cases. So we'll come back to that later. Finally, we update modifier opcode. One of the benefits of the Glimmer VM is that opcodes are simple both conceptually and in implementation. In this case, we can see that, or we know that our action modifier doesn't have any dynamic arguments. It's simply got a toggle string, which is constant. So if nothing is dynamic, we actually don't need to update an opcode or emit an opcode. So this is cool. It's emitted a PR with this tiny little change. If the args are constant, don't emit update opcode, and we could do less work on initial render and on update. I think it's a real testament to how conceptually simple Glimmer is, that someone like me with no computer science background or experience with compilers or virtual machines can make simple performance improvements like this. So the next set of opcodes we've seen before: flush the button, append some text, close the element, open a second button. So this is going to use the classic action, which is going to, or closure action, which will create a function and set it to the onClick. So it receives an expression. In our case, it's a compiled helper, which has some arguments, and a helper function, which is Ember's built-in action helper function. So we eval the args, wrap them in references. Then we call the action helper with these args, and this looks up the action function on the target, which is the toggle action again on our application controller, and it returns a function that closes over that action, hence the name closure actions. We'll see this again when we look at how events are delegated. Finally, we set this newly created function as the operand on the current frame. Dynamic adder takes the recent set operation as the operand, which is our action function, and sets it to the onClick handler for our button. I think this is an opportunity for us to make an easy performance improvement. Again, if all the inputs are static, which they are in this case, we could update the compiler to emit a static adder opcode instead of a dynamic adder. You can see how that's so easy to understand. We then flush the remaining, or flush the button, append some text, and close the button. So we're almost done with this initial render. One final step remains, which is, I mentioned earlier that a render is, executing the opcodes is wrapped in a transaction. So we can now commit that because we're finished. And this is going to install an action modifier that we created and scheduled earlier for the classic action button. So it looks something like this. We have our action state, which we registered earlier, and this gives access to the DOM and the element that we're installing the modifier on, and a unique ID for our action. We then register the action state object to some internal hash in Ember, which provides access to a list of currently registered actions. And then we set some attributes. The bottom one includes the action ID. So when we click it, we have enough information to go look up this object again. With that, we complete the append transaction, and we're done with the initial render of our app. It says here 37 minutes. Am I 37 minutes in? Am I 37 minutes in? All right. Okay, all right. Okay, let's look at action dispatch. So here's our classic action button. The event handler is on the body. And here's a reminder, this is the HTML for the button. And here's the body click event handler that we register at boot time. I've used some pseudocode here just to make the code fit on the slide. So on click, we grab any attributes from the current target element. So even though we're firing an event on the body, we've also got access to whatever element where the event occurred, which is called the current target. So that will be the button in our case. We then iterate over its element attributes, looking for an attribute that begins with data ember action. And if we find one of those, we look for the registered action ID, and then we look it up from this registry of actions. So this is this action state thing again, and it's got knows where the target is and what the name of the action is. We then compare the event name. So if it's a click, and then we invoke this action. So here's the handler for this action. First thing we do is get the target, which in our case will be the application controller. And then within a run loop, something I'll explain soon, we send the name of the action, toggle in our case, to the target. And this invokes the toggle action and toggles the show image property on our controller. For the button with the closure action, as we've seen, clicking it invokes the click handler, which the append VM attached to our second button directly. And this is what the click handler function looks like. We essentially invoke the toggle function on our controller instance, again, within a run loop. Closure actions, by the nature of being very simple functions, allow us to pass them into components and invoke them wherever we like. And also notice that these functions can have a return value, something that classic actions can't. And these are two things which make closure actions so attractive. So finally, let's look at the update VM. So here we're looking at the VMs just after initial render. You can see the DOM has an image and two buttons. So let's click the classic action button. It doesn't matter which one we click, they're both going to invoke the same action. As we've just seen, this dispatches a toggle action to a controller, which toggles the show image property within a run loop, so true to false. To understand how this triggers a render or a re-render, we'll just take a little detour into the run loop. So the run loop is a series of function queues which are processed in a particular order. Having this mechanism allows Ember to schedule different types of work and for that work to be executed in a controlled sequence. So function queues are processed from left to right, and functions with each queue are processed one at a time. Each time a run loop is created, so for example, when we execute an action, Ember schedules a re-render function in the render queue. And you can see this happens after our toggle action is executed. So toggle action first, then our re-render. So this re-render function will check if any dependent data has changed, and if it has, execute the update virtual machine. I didn't animate it here, but the try up code creates a new frame on the update VM, very much like we saw with the append VM. And next we have a third opcode. This receives a cached reference, which wraps our show image property. We do a cheap check to see if it's modified. If it hasn't, we're finished updating. In this case, it has changed from true to false, so we call vm.throw. This does two things. It removes any DOM which should no longer be displayed, in our case, the image. And it emits and runs append opcodes for any new DOM that needs to be rendered. So in this case, we'll blow away the image from the DOM and emit 3 opcodes and process them in the append VM. So we've seen jump unless before as part of initial render. We grab the reference, wrap it in a cache, peek at its value. This time it is false, so we tell the VM to jump to its target. If our if statement had an else clause, we jump to the else clause. As it doesn't, we jump over the remaining opcodes, and we're done. The image has been removed. Now, if we trigger the action again, we run the opcodes again. This would blow away any DOM if we had the else clause, but we don't. It then emits 3 opcodes again, as before, in the jump unless. This time, it doesn't jump over it, so it renders just in time, compiles the wire format, renders our image. And then this brings us, again, right back to the exact state that we were after initial render. So that's all I have. It's been a lot of fun creating these and getting to know Ember internals a little bit. Glimmer is a really great technology, so if you've any applause directed towards Yehuda, Godfrey, and Chad, and different people on the Ember core team who imagined up and built this amazing machine. Thanks.